Hello everyone, welcome back to the channel. Today I'm continuing with small change under differentiation. There are a few things I need you to have in mind. Whenever you are working the question on small change, okay, assume that your calculator must be in radians, okay? If they want you to do it in degrees, the question will state it. Otherwise, it has to be in radians. All right, keep this in mind always, because you look at this question. Okay, the first question that we are going to solve today, there's no indication that it's in radians. There's no indication that it's in degree. Of course, this is a question that we will not solve. It has nothing to do with it. If you look at this next question, there's no indication that it's in degrees or radians. Followed by this one too, same thing. Of course, this is this guy has nothing to do with what we are doing, so I'll take it out. And then question number 8 to if you look at the B part, has no indication whether it is going to be degrees or radians. So basically, this is how Cambridge sets their questions. Okay, but for this purpose, I just took from 2020 to 2021, all right, questions that have come under small change. Okay, why did I do that? Well, because that's current. All right, we want to see how Cambridge is thinking now. All right, so without wasting much time, let's just dive right into it and start solving. Okay, and if you haven't subscribed already, please do so. All right, you know I never disappoint. All right, so let's start with the very first question. It says that variable x and y such that y is equal to sine x over cos x. Using differentiation, find the approximate change in y as x increases from negative pi on 4 to h minus pi on 4, where h is very small, indicating that this is a small change that we're looking for. So basically what happens is that the change in y divided by the change in x, okay, is approximately equal to dy dx. All right, basically this is the argument. As your change in x approaches 0, the ratio of change in y over change in x is equal to dy dx. Okay, as the change in x approaches 0. That is very, very, very minute. So if they want you to find change in y, then it means that change in y is actually approximately dy dx, okay, times change in x. So this is the idea that you need to keep in mind. All right, this is the basic concept that you are going to apply throughout. Okay, so let's start with this particular question. Now, if you look at what we have, it means that we need to differentiate y with respect to x, and also we need to look for the small change in the x, right? But let's start with the differentiation. So we have sine x over cos x, right? So this is a quotient, okay? So first, your dy dx, okay? Differentiate the sine, that gives you cos, okay? Cos x. Then you keep the denominator, that's cos x. And then minus, now you keep sine x constant, and then you differentiate cos x, and that would be negative sine x all over cos square x. All right, so that means that you have cos square x plus sine square x all over cos square x. But you know, cos square x plus sine square x, that is 1, so you have 1 over cos square x, and that is basically sec, right? So well, if you have this, well, I wouldn't say much. I'll just tell you to don't convert it to sec or anything like that. Just keep it like that, okay? So your change in y is approximately dy dx, okay, but it is dy dx, all right, at the initial value, and the initial value is negative pi on 4. So you have cos negative pi on 4 all square, all right, times the small change in x. Well, x, change in x is the final, which is this guy, all right, minus the beginning, all right, and this will give you h, okay. So you have h there. So when I put everything on the calculator, basically you keep the h and then just do 1 over cos. Make sure that the calculator is in radians. I nearly worked in degrees, so please make sure that you change it to radians to avoid any surprises, okay? Because you'll be doing the right thing, and at the end of the day, you are wrong, all because you were working. All right, so this is actually 2h, right? So please make sure that you are working in the right measure, that is radians, okay? All right, so this is how to go about the question. So let's go to the next one. This one looks quite interesting. It says that the variable x and y are such that, I gave you the plan that basically we are going to use, they want us to find approximate change in y. So change in y is approximately dy dx times change in x, right? Okay, so we have this idea. This is all you need when it comes to small change, friends. This is all you need. So now, if we have y to be equal to e to the power 3x sine x over x squared, then we just have to differentiate it. So let's differentiate it and see how that goes. First, we will differentiate the numerator. The numerator. So remember that the numerator is two functions that are multiplying. So we use the product rule of differentiation, okay? So that means that we have, I can keep the sine x constant and then differentiate the e. That will be 3e to the power 3x, okay? Plus, now I keep this guy constant, and then I differentiate sine, giving me cos x. All of this, I will now keep the x squared there. Minus, now I keep all of this constant, and then I differentiate x squared, giving me 2x. All over this to the fourth power, because you divide by the square of the denominator. All right. Now this is looking beautiful, but we just have to simplify a few things and we are good to go. So I'm going to have, this will be 3e 3x sine x, all right? Even if I want to open up, will it help me? Maybe, yeah, maybe no, but who cares? Hold on, let's see if there is something good here to make us open this guy up. If not, we will just put the answer there like that. All right. Okay, so if we have something like this, remember that what is the beginning? Well, this is the beginning. All right, so that is the x value that we are going to use. You can put the whole of this on the calculator, but I was hoping that this particular value would have something to do with this. But I just realized that we have x squared here and there's no x squared. So I'll just be wasting my time. Or it will just be about simplifying things. Maybe simplifying things will help. Or we can just put it on the calculator, okay? X is 0.5, so let me just put everything on the calculator. That way we don't waste time. Right, because what they really want is the small change. They don't want us to simplify anything. So to the power 0.5, okay, sine 0.5 plus e to the power 3 into 0.5 cos 0.5 all times 0.5 square minus 2 into 0.5 e to the power 3 into 0.5 sine 0.5 all over 0.5 to the fourth power. Whoa, calculator tells me math error. I think the value is too much. I need to simplify. Let me see. Maybe I didn't bring times in some way. If after all this, it keeps telling me math error, then that means that we just have to simplify a few things. I didn't want to do that, friends, honestly. But seems like I may not have a choice other than simplifying something. Still, so let's simplify. Right, so I'm going to have 3x squared e to the this sine x plus x squared cos x e to the power 3x minus 2x this sine x all over x to the fourth power. Okay, now if I take this friend and that friend, they have sine, so I can just factor out sine. In fact, e to the power 3x sine x, and then I'll be left with 3x squared minus 2x, all right, plus x squared cos x e to the power 3x. All right, okay, so all over this guy to the fourth power. Now that I've simplified it a little bit, let's see if it will help. So that means we have e to the power. I'm sure that when you also gave it a try, you realize that it was math error. I don't know why the calculator can't process this. Is a calculator supposed to do that? Why? Because we humans, sometimes we don't want to think with our brains when there's a calculator, right? Yeah. Anyways, so I'm done with this guy. So 3 into this guy square minus 0.2, okay. All right, plus 0.5 square times cos 0.5 times e to the power 3 into 0.5. Okay, all divided by 0.5 to the fourth power. Right, this time round, what is the calculator saying? Oh, okay, now it works. Great. So this time our calculator is saying that the answer is 7.14. What I did was that I put the initial value there because I told you already that when you work and you get to this part, you are going to use dy dx, and that is what I've differentiated. Just I'm trying to cut corners. So this is basically dy dx as x gives 0.5. Okay, that's the initial value. So we got that. Can we just maybe probably write it down here that change in y is equal to 7.14 times the change in x. But the change in x, remember that for change in x is starting from 0.5 and is going straight to 0.5 plus h. So that means that the change in x, all right, is the final value 0.5 plus h minus the initial value giving you h. So you have this guy. So your answer is 7.14h. Basically, that is what you should get. Okay, so that's a small change in y as a result of x increasing by a small value called h. All right. Okay, so this is it, and then this is the next question that we need to take a look at. It says that the variable x and y are such that y is equal to sine x plus e to the power negative x. Use differentiation to find approximate change in y as s increases from pi on 4 to pi on 4 plus h, where h is very small. So like you can see, Cambridge hasn't changed the question when it comes to small change. It's just old same approach. So you just need to know that your change in y is approximately dy dx, okay, times your change in x. Can you find the change in x? Yep. If it's increasing from here to here, that means that the small change is what? H. So that's fine. But your main job is to differentiate that particular function. So y is equal to sine x plus e to the power negative x. That would mean that your dy dx will be cos x plus negative e to the power negative x. Okay, now what you really want is the initial. So dy dx from the beginning, when x is pi on 4, would be cos into pi on 4 minus e to the negative pi on 4. And what does the calculator say? Cos pi on 4 minus e to the power negative pi on 4. So calculator says our answer is 0.251. All right, so that basically means that your change in y is approximately 0.251 times h, giving you 0.251 h. So that is the answer you are looking for. I mean, this is really straightforward, and no one is going to be confused. If you probably have a question, you can ask that in the comment section, and I'll link the worksheet in the description so you can check it out and then practice alongside with me. Right, probably this is our last question for the day. I wanted us to do about 20 minutes, not more than that. I mean, previous questions we used to solve like an hour or so. Today I'm really tired, so we will do like 20 minutes. So now this question says that differentiate y is equal to tan into bracket x plus 4 minus 3 sine x. So basically your dy dx, okay, if you differentiate tan, you get sec squared. So you get sec squared, this whole thing. Then you go inside the bracket and you differentiate with the value in the bracket. That's basically 1, because x, you differentiate x, you get 1. Then you have your negative 3, okay? But if you differentiate sine x, you get cos x. So your answer is basically sec squared x plus 4 minus 3 cos x. All right, good for us for 2 marks. Then they are telling us that the variables x and y are such that this is your y. Use differentiation to find the change. So I mean, I have a question. Why is it that Cambridge, they don't say that use differentiation to find the approximate change in x, as y probably changes from somewhere to somewhere? Check like it's always find approximate change in y when x, well, if they are predictable, it helps students, right? So let's celebrate in that. Okay, so we need our dy dx. All right, this is quotient. So I'll start by differentiating the ln. And now if you want to differentiate a ln function, okay, let's say you have ln f of x, okay. Now that would be very confusing. Let me just make it ln ax plus b. Okay, so what happens is that you differentiate the inner function, which is this guy. When you differentiate, you have only a divided by the inner function ax plus b. So this is how we differentiate natural log. So if I differentiate the inner function, I'll get 2, okay, divided by 2x plus 5, okay. So that's it. Then you keep the exponent, the denominator constant. All right, let's erase this. We don't need it again. All right, minus. Now we get to keep this guy constant and then differentiate the denominator. That will give us 6e to the power 3x. It's 6 because the 3 comes down to multiply the 2, giving us 6, or divided by 2e to the power 3, this guy, all squared. Okay, yep, it's okay. So that means we have 4 e to the power 3x over this guy minus 6e3 this ln 2x plus 5 all over. Now be careful here, that will give you 4 e to the power 6x. All right, so we can find, I don't want us to simplify things Can we just put it on the calculator? Yeah, but I know it's 6 marks, and you may be thinking that what if we make a mistake? Yeah, while we are simplifying. Yeah, that's why I want us to just put it on calculator and be free. Okay, so if we are going to put it on the calculator, so then if the calculator tells me math error, then I'll simplify. Remember the first question that we had that issue, yeah. Now the initial x value, okay, according to the question, is actually 1. So this is when x equals 1. So that means that I have 4e to the third power over 7, okay, minus 6e to the third power, ln 7, okay, all over 4 into e to the 6th power. I think something like this, the calculator can process it. So we have e 4e to the power 3 over 7 and then hold on, I think, yeah, so it's 4e to the power 3 over 7, okay, minus 6e to the third power, ln of 7. This is very beautiful. E to the 6th power. Okay. Right. So according to the calculator, I should get negative 0.138. Okay. So that is the derivative. But you know what we do? We do our change in y is basically the derivative that we got times the change in x. But the change in x, change in x is from, x is from 1 to 1 plus h, so it means that the change is basically h, so that our answer is negative 0.138 h. What this means is that there is an inverse relationship between x and y. While x is increasing by a very small value called h, y is decreasing by a value called 0.138 times that small change that resulted in the x component. Right, so basically this is how we solve small change questions. You should find a worksheet in the description, give it a try. Right, this question is May, June 2020, and I think the very first question that we solved was May, June 2021. So these are, this is basically how Cambridge likes to set questions on small change. In our next video, okay, I'm going to work on rate of change, okay? So look forward to that video. Maybe it will help you out. So until we meet again, stay safe. Bye for now.